Welcome back. In the last video, we said an LLM is just predicting the next token, which feels a bit odd considering what it can do. But before we start looking at every piece in details, let's take a step back and look at the whole picture. Today, we're going to follow your prompts on its full journey. You type something in, it disappears into the machine, and a few moments later, an answer comes back, like it actually knows what it's doing. What's happening in between? Who are the actors involved? Where does your prompt go? Who touches it? Who transforms it? We're going to look at the entire path your prompt takes together, so by the end of this course, it doesn't feel like magic anymore. Okay, let's start from the beginning. When you send a message to an LLM, here's the full journey it takes. The first step is here. Your text gets turned into tokens. The model doesn't read words, it reads numbers. So the first thing that happens is your texts get broken into chunks. That's what we call tokens. And each one gets converted into a number. The second step is about these tokens that get turned into embeddings, which essentially are vectors. Each token number maps to a vector. This is where language starts becoming something a neural network can work with. Then we have the third step. The embeddings pass through transformer blocks. This is the main core of the model. Multiple layers of attention and multi-layer perceptron that progressively build an understanding of context and meaning. Then we have the fourth step. The output layer produces probabilities. After all these transformer blocks, the model outputs a probability distribution over every possible next token. Which word is most likely to come next? That's the question that we try to answer. And the final and fifth step, a token gets selected and decoded back to text. The highest probability token gets picked and converted back into readable text. Then the whole cycle repeats for the next token and the next one and the next one until the response is complete. That's the full pipeline. Let's walk through each one a little bit more slow. So the step 1 and 2 happen before the model even starts thinking. Tokenization takes your raw text and breaks it into chunks. It's not always a full word. Sometimes it's parts of words. Sometimes it's punctuations. Sometimes it's a whole phrase. Then each token gets converted to what we call an embedding. So it's a vector of hundreds or sometimes thousands of numbers. You can think of an embedding as a coordinate in a very high dimensional space where tokens with similar meanings sit close together. For example, if we take king and queen, they have embeddings close to each other. Function and method in a coding context will be close. Semicolon or pares will be somewhere very different. These embeddings are what goes into the transformer. It's not the word or the tokens, but those very specific vectors. We'll go deep on tokens and embeddings in a later video. But for now, just know the text comes in, the vectors comes out, and those vectors are the ones that carry meaning. So The transformer block is the heart of the model. And here's the key thing to understand. There isn't just one of these. A modern LLM might have 32, 96, or even 128 of these blocks stacked on top of each other. Each one refines the representation a little bit more. Each block has two components. The attention block. This is where the model figures out which part of the input are relevant to each other. For example, when processing the word it in a sentence, attention figures out what it refers to. Remember, the LLM has no idea of grammar rules. So when processing a function call, attention connects it to the function definition earlier in the context. It's the mechanism that gives LLMs their ability to handle long, complex input. Then we have the MLP, the multi-layer perceptron. After attention has identified what's relevant, the MLP processes and transforms that information. If attention is about what to look at, the MLP is about what to do with it. Between those two components, you'll also see layer normalization, which keeps the numbers stable during training. And we have also the residual connections, which let informations flow around blocks rather than only through them, which is critical for training deep networks. After passing through all the transformer blocks, the model has built up a rich representation of your input. Now it needs to make a decision. What token comes next? The output layer, called the language model head, takes that final representation and projects it into a probability distribution over the entire token vocabulary. Every possible next token gets a score. Those scores get converted to probability via softmax. I want you to remember softmax. Then a token gets selected. How? This is where sampling comes in. It's controlled by parameters you may have seen before. Temperature. At higher temperatures level, lower probability tokens get more of a chance, which makes the model more creative. For example, it could be used for creative writing. At temperature 0, you always pick the highest probability token, the one that is predictable, which is good for code regeneration since we need deterministic results. This is why the same prompt can give you different answers each time, and why you can tune that behavior. Okay, so now you have the full picture. Let me show you exactly how our remaining videos connects to what you just learned. So the next video will be about neural network and how they actually work. Next, we'll see how LLMs are trained and how the whole system learns. Then we will see tokens, the first step in the pipeline. Next, we have the transformer architecture, the container of everything. Then we'll see the attention block, the most important mechanism inside of it. And then we have MLP, multi-layer perceptron, what happens after attention. Then in the video 9, we'll see the full transformer block assembled. Then we will discuss of why this matters to you and how it can make you a better engineer. And finally, we'll look at how to use all that knowledge to put it into your workflow. Every video from here is a deep dive into something you saw today. You'll never be lost wondering why it matters because you've already seen where it fits. Your assignment for today is simple. I want you to open any LLM API, OpenAI, Anthropic, whatever you use. Find the parameter that controls the temperature. Try the same prompt with temperature 0, 1, and notice how your inputs differ. Share your observation on Discord. Okay, it's time for a quiz. So the questions that I have for you, I wanted to name the 5 steps in the end-to-end LLM pipeline in the order, of course. Then I wanted to tell me what is the difference between a token and embedding. And then last question would be, what are the 2 main components inside the transformer block? That's it. I'll see you in the next video.